Okay, after having detected the violation of that criticality aware modeling rules, um, we can perform model edition to fulfill them. So we can, for instance, do this remapping of the application component instance to the memory spaces and use more memory spaces to ensure that separation. And it is obvious that we should expect from this remapping that this error should not longer appear. So to check that, we save the model with a new remapping, and we will delete the error log to avoid any confusion and to show only the report after passing the new validation. Then we can pass the validation, and what we should expect is that the error stating that components with different criticality are mapped to the same memory space is not longer appearing. Moreover, what should happen with the other modeling rule, that is coherent criticalities between the platform independent model component instance and the platform resources? We can see that the errors in this case have also disappeared. So why? Well, as we said, we have now only components with the same criticality mapped to a single memory space. And for understanding why the error referring to incoherent criticalities in different, let's say, levels, that is application and platform resource level, we can realize that the memory partition which or where all the safety critical functionalities is mapped to is in turn mapped, as we can see here, is in turn mapped to an RTOS instance which has not criticality level associated, but which is in turn mapped to the CPU4 microblaze core. And as we can remember, this microblaze core has also a safety critical level 3. So there is a coherent mapping. The platform independent components of criticality level 3 are mapped to a resource with criticality level 3. Notice, or it is remarkable to see that to try to track this in the model, once we are exploiting this separation of the information and of the perspectives, is not that easy to track. And the validation tool has made our lives easier in this case. Can be the same said for the other memory spaces and platform independent components? Well, if we come back to them and to the memory space diagram, we can see that the mission application component is mapped to this new MS mission memory space, and the monitoring and debugging functionality is mapped to a new memory partition or memory space called MS non-critical. Then we need to go to the architectural view again to see where these memory spaces have been mapped to. We can see that they have been mapped to an RTOS instance, and that in turn this RTOS instance have been mapped or allocated to this SMP platform, that is the sync processing system, or in other words, the CPU1 and CPU2 of type ARM Cortex-A9. And as we can remember, these processing cores were associated a criticality level 2. So eventually, this means that application instances of criticality level 1 and criticality level 2 have been mapped both to resources of a criticality level 2. Well, for the mission critical part, this is clearly a coherent mapping. However, this is not a kind of coherent mapping if we, let's say, enforce the same criticality, exactly and strictly the same criticality level. However, in our methodology and our domain, we understand this not as an error. Is not the topic of this talk, but by different reasons, we assume our hard techniques to enable the mapping of functionality of these levels of criticality to the same operating system. So for this case, the tool has been configured to report this situation just as a warning, as you can see here, stating that this lower criticality component has been mapped to resources which have a higher criticality level 2. Here are some notes of why this is reported as a warning and not as an error.